All right, I think we're live. Welcome to this session about infusing generative AI in your Java applications with LangChain4j. Yeah, so another session about AI. I'm sure nobody's seen any today. It's, of course. But yeah, the nice thing with AI is it's not just for data scientists. We, as you know, maybe the more traditional developers, we can actually leverage it as well. So in this session, we're going to see how we can do that with a fairly popular library with Java, and then I'll show some examples of how to do that with Quarkus in particular. So my name is Kevin Dubois. I'm a developer advocate at Red Hat. Also a Java champion. I'm based in Belgium, so fortunately I didn't have to travel too far. And yeah, there's some information about me. So when we look at AI, we can kind of divide it a little bit between, on the one hand, on the one side, we have, like people who are building models or fine-tuning models and everything. Then kind of in the middle, we have, some way to serve the models, or, where to store the models and everything. And then, kind of on the right side of this divider is, our traditional, let's say, application frameworks, right? So including Java, Node.js, Python, .NET, and other languages that can consume these messages, right? So we saw in the previous session with Ugo that AI models are basically just serving APIs, right? So we're consuming these APIs on, in this case, the Java side. So we're going to look specifically into how to do that in Java, and then we're going to use this this particular project with the cute little parrot there, which is LangChain4j. So LangChain4j is a nice Java library based on the Python LangChain library to integrate AI capabilities into your Java code in a fairly straightforward way, because yes, you can do it without without a specific library. You can because it's just APIs, right? So you can write everything from scratch, but why would you do that, right? Why reinvent the wheel? So LangChain4j's come out as, at least in the Java world, as the most popular library at the moment. So that's the one that we're going to look at. So if you want to start using LangChain4j, basically, in the Quarkus world, but for Spring Boot, it's fairly similar. You just add the LangChain4j dependency. So in this case, we're, in my example, is using LangChain4j OpenAI, but it could be, Hugging Face, Mistral, watsonx, Claude, whatever. So it supports all these different LLMs as well. So, and really, that's a fairly straightforward way to get started. So I'm just going to show that real quick. So, you can create a Quarkus or Java application with Quarkus in a few different ways. In this case, I'm just going to say Quarkus create app, my AI app, I don't know. And then just add an extension, LangChain4j-OpenAI. And so basically, this is going to create a really simple application, right? With with the LangChain4j dependency. And of course, I would have to write some business code, but maybe I just want to try out some calls and see how this particular model is working. The one from OpenAI in this case. So I can just start this application on my local machine. So if I do. If I go into this library, LangChain, it's my AI app, and then I start the application. So in this case, I'm using Quarkus, right? So we can just do the Quarkus dev mode. And what's kind of handy with Quarkus is that it also has this dev UI, and we can start trying out some stuff. So I'm just showing this kind of as an interesting place to get started with LangChain4j. So if you go then to localhost 8080, we are unable to connect. Let's see if it has started up. Is it running on port 8080? I don't see where the port is. I'm just going to stop it and start it again. If not, we'll run it from a different project. It by default runs on localhost 8080 unless I typed in something else. All right, so we'll see if it's running. Maybe I need to expose something first. But anyway, let's try it real quick. So localhost 8080, and then q/devui. That's where devui is. Anyway, let's go to. Yeah, that's the debug port though. So it shouldn't be running. It should also be running on port 8080. So I'm going to do it a little bit differently. I'm going to go to an existing project. I'm going to stop this. And then open it here, and then, wow, we'll go ahead and restart the fun of live demos. It's funny because I'm like, oh yeah, I already have it prepared, so we're good to go, but yeah. All right, so let's do it here. Quark is dev, so this is another little project that I already created. I'll show this more in a second. I'm just going to make this a little bit smaller. So this should start up in just a second. In the meantime, I'm just going to go back to my slides, and then we'll revisit this in just a second. So what you would have seen is a Quark is dev UI, but I'll show that in a minute. So with LangChain4j, you have a few concepts, right, to work with these AI models. So the first concept that you've probably heard of is prompts, right? So basically a way to interact with a model. You send a question or a message or something, and then it replies. And then you can also, with LangChain4j, populate your Java class, so you can do some marshalling and marshalling based on this as well. So the way that you would do this is, you might configure an API key to interact with the model if it requires that. And then the main thing here is this interface assistant with this register AI service, right? So that annotation basically enables you to use the AI. So that wires it up for you, and then you can inject basically this, this interface into your code, and then you can call it, right? So you can, for example, add a system message that adds some context to your call. In this case, you are a professional poet. And then we can, add a message with the user message annotation that says, write a poem about a specific topic. And so this topic is in curly braces because it's basically a placeholder, so you can use variables in these calls as well, right? And then the poem should be X lines long. And then basically this would, return, of course, a little poem about, a topic that you pass into it. And then going a little bit further, you can also just marshal objects. So you can say, hey, extract information about a transaction from something, and the LangChain4j and the model response is actually able to translate that to specific components or objects in your code. So that's very handy as well. So the prompting is the first concept in LangChain4j. Then the next concept they have is memory. So if you have seen LangChain4j in the past, as the name kind of implies, LangChain, they had chains. They've kind of deprecated the chains part, and now it's called memory. But it's kind of the same idea, because the idea is that, well, you make a call to the LLM, right? You tell it, hey, create some code for me, and then maybe you send a second call, create a test of this code. And so if the call doesn't remember the previous call, then it's going to say, well, test for what code, right? I mean, I don't know what you're talking about. And so thanks to the memory component, you're able to keep a memory, of previous calls, and you can actually have multiple parallel calls at the same time as well. So the way that you would do this is by providing a chat memory provider supplier. And actually, you don't have to do that with Quarkus, because the one example that I show here is the default, so you don't have to provide that. It has this memory built in. but that's an in-memory provider, right? So you can also use different providers that maybe use a caching engine or something, but that way you can keep track of specific conversations. So in this case, you can see, can you give a brief explanation of Kubernetes, and then in the second call, can you give me a YAML example to deploy an application for this, right? And this references the previous call. So that's how it is able to memorize this. Then you also have this at memory ID, and basically you can add IDs to the calls that you're making, so you can have multiple conversations at the same time. Like in this example, you can see we're first making a call and saying, with ID 1, I'm Frank. With ID 2, I'm Betty. And then the third call is, who am I? And then, it would, of course, reply with Frank because we reference ID 1, right? So conversation 1, not conversation 2. So that's how memory works with LangChain4j. And then we have also the concept of tools. Tools is really powerful because now you can actually mix business code with your, with your AI calls. So you can say, I have some deterministic parts of my code that I want it to do, right? Because LLMs, what they will reply is going to vary, right? It's never going to be exactly the same because it just kind of generates it on the fly. But maybe you want to add some business code. Maybe you want to, based on the answer, take some action, right? So you could, for example, send an email, right? So how you would do that is you would annotate your business code with this @tool annotation, and then you write some text, and it's natural language, right? So send the given content by email, and then this method basically sends an email. And then when you do your register AI service, you reference, this tool email service, right? So you reference that class, and then in your user message, you give it some message, and then again in natural language, you say, then send this poem by email, and the AI model, the response is able to link those two together based on the tool component. Says, then send this poem by email. That probably matches with, the instruction of send the given content by email. Even though it wasn't exactly the same text, it's able to, tie it together. So it's, a little bit smarter than just having exactly, deterministic calls. So let's try it out in our code, and hopefully my dev mode will work this time. Oh, good thing my backup finished. So let's see if our Quarkus dev mode is running right now. So it looks like it's running on localhost 8080 this time, which is great. This is a teaser for our next demo. Localhost 8080, and now we can see that our application is running, which is great. And so, like I was saying, in Quarkus Dev UI, you have these helpful components, right? So basically, because I added the LangChain4j dependency, we can see here that it shows me all the AI servers that I've registered in this particular application. We can see also that I've registered a tool, which is the email service. And I can even, create, test out the model from the dev UI here. I can even send a message like, what is WeAreDevelopers World Congress? And then we can send that, and it, would call the model that I've tied into into my application, right? So that's an easy way to kind of see if the model is good, and you can actually also even generate images. So you can say like, oh, I want to use DALL-E 2 or 3, create an image of WeAreDevelopers or whatever. So just to test out your models, right? So in this case, of course, I've already created a little bit of code. So based on the examples that I was shown, right? So you can see in my pom.xml that we have the LangChain4j OpenAI dependency, and then I also added a Quarkus mailer, which is basically a way to send some emails, and then the MailPit extension. So basically, when I'm testing on my local machine, I want to spin up local mail servers so I can actually see if it's working or not. So I have now registered a couple of AI services. So this one's very basic. So there's the system message that's basically gives the context. You are a Java developer, and then write a haiku about a specific topic, so we can test that out in a minute. So we have here this chat resource on the /chat endpoint with a query param of topics. So if I go to my local host 8080 /chat, and then what was it, topic, I think, equals we are developers as the topic. Let's see what it does, right? So it created a haiku. Code echoes in halls, mindful creators gather, we are developers. Wow, it's very deep, right? So that's just creating a prompt, right? But so I actually created this into another resource, my email resource here, which is basically the one that also will send it in an email, right? So the same topic, we are developers, World Congress, and then here we have the AI service with the register AI service tools equals email service, right? So there's my business code with the tool annotation, and then my system message is pretty similar, right? You are a Java developer, write a haiku, and then email it, right? So we're telling it to email it, and that's going to go to my business code and send the email. So let's try that out. I think it's running on, I have to go look, /email. So if we go to localhost /email, let's see if it works, right? So we're going to ask our LLM to create a haiku and then email it. So in this case, it says, we are developers, World Congress, full of knowledge, tech minds come alive. And so let's now see if that actually sent the email. So again, in my Quark is dev mode, I also have the email extension in this case. And we can see here in this MailPit that we have a MailPit UI that just starts up because I'm in dev mode, right? So it just does that on the fly for you as you're developing, and we can see an email for me has arrived with the haiku. So it actually did work, which is great, right? So those are some examples of how to get started with integrating AI into your Java code. So there's a couple more things that you can do, though. So you can also embed documents. So you may have heard of RAGs, or Retrieval Augmented Generation, I think it stands for. And so basically, you can add your own kind of business documents to this knowledge base, right? So the LLM doesn't have, like OpenAI in this case, doesn't have knowledge of my particular business's terms of service or something, or my particular knowledge of my business, right? So what I want to do is, instead of retraining an entire model based on my knowledge, which is one way you could do that, you can also add these documents to the call, and then it would use that additional information to give you specific answers with your particular knowledge. So you can do this in two ways. So the first way is embedding, adding some content, some knowledge into an embedding store, and then you could use, for example, Redis, but it could also be pgvector, Chroma. There's a whole bunch of different providers that you can use where you can store that data, and then when you make your call, it's going to add that, those vectors, right? Because it works based on, pointers to this information. It doesn't, send the whole documents. It's using these vectors. But anyway, so you can add your documents. It's going to, split those into chunks and then put them into your document store, and then you can retrieve them when you make your call with this embedding store retriever, and then basically say, do it with 10 tokens at a time or something. Anyway, and then basically then when you make your call, when you create your AI service, you add your retriever supplier to tell your code that, hey, add this information to your call. And so that's one way to do it. Quarkus in particular has added this new feature, which is Easy Rag, which makes it a little bit easier for, let's say, more straightforward use cases. And in this case, you add this LangChain4j Easy Rag dependency to your application, and then you can just put in your application properties, hey, grab the documents that are in this source main resources catalog folder, and then just vectorize those and send them to the LLM. So we can take a look at that, and of course, because we like to do chatbots as AI samples, right? So I'll create a chatbot in this case, and I'll add some information about my particular use case, which is this basically this booking service where I want, if somebody wants to cancel their booking, they can only do it, if the booking has been made, or when my booking is more than 7 days away, right? So I have these terms of service document in my application. So I'm going to close this and open my new one, where it basically describes this. So I'm going to open it. It's in the RAG example, so code RAG, and then I'll show you real quick how that works. Yeah, sure, restart, I guess. And then you can see here we have in our application properties, right? I have this Easy Rag path. I'm also setting the temperature. So temperature basically means like lower temperature is going to try to be more deterministic. When it's a higher temperature, is going to try to make up a lot more. So in this case, I want it to be pretty strict. And then in this case, I just have a very basic example. So I just have this one booking of John Doe with this booking number. And my booking starts in 1 day, so it should reject it, right, if I want to try to cancel it. Because I have these terms of use in the catalog that basically says if reservations is within less than 7 days, then don't allow the cancellation. So then in my AI assistant, I have in the system message, basically I'm telling the LLM, like, hey, read through this document and then make sure that you do not allow to cancel based on the information in that terms of service document. And then I have a WebSocket here. So on open, we're going to show hello from Miles of Smiles. That's our car booking service. And then we basically have this chat, right? And of course I have a UI, but yeah. So I'll start this up, and then we'll see if this works. So we're going to, again, run this all on my local machine. I like to do my development on my local machine. So we're going to see how this works, right? So Quarkus dev starts up, and then in just a second. So it's now loading that document and making sure that that's part of my calls. You can actually cache it as well in between different calls within your dev service as well. You can also use, even with this Easy Rag, you can use a data store as well, by the way. So our application has started up. So I'm going to close this and then hit refresh here on my localhost 8080. So we have our chat bot here, right? So hello from Miles of Smiles. Miles of Smiles, how can we help you? And I say, I want to cancel my booking. And so it should answer in a minute, hopefully, if everything goes well. And if it's not answering, that means that there's an error. Because, of course, we're doing a live demo, and so blah, blah, blah. What's it saying? Error, invalid requests, error ID. Wow, this is interesting. Let's see real quick in my application properties. Should be fine, but let's see if we use a different model real quick. So I'll restart for just a second. I love how you test this out 10 times before your talk, and it works every time, and then you're on stage, and it's like, oh yeah, I'm going to play some games with you, Kevin. All right, so let's see if it works. If not, I have one more backup project. So you did see, so all these numbers are the vectors, right? So the document is scanned, and then it's creating all these vectors. So let's try it one more time. We're going to refresh here, localhost 8080. cancel my booking. And no, I don't see it answering, so I'm going to, oh, it did answer. I just was not patient enough. All right, so let's try that again. Localhost, okay, cancel my booking. Okay, be patient, Kevin. All right, there we go. So the LLM basically answered. It says, I'm going to make this a little more visible. So it says, yeah, we can try to cancel, but I need your information, all right? So the booking number was 123456, and then the name was John Doe. And we're going to send this, and then it's going to, verify if my booking can be canceled, because in our terms of service, we said you cannot cancel it if it's within 7 days. And sure enough, it says, reservations can be canceled up to 7 days. Since the booking starting date is tomorrow, which is less than 7 days, you cannot cancel, right? So it is actually able to determine whether I can cancel or not. And we can play around with this now. We can say in the application, well, this would probably come from a database, not in your application properties, but I'm going to set my start date to 10 in this case. And then I'm going to do a booking for 20 days. And then let's go back to our test here, hit refresh. And then let's see what happens if I cancel my booking again. And it's going to answer again that I need to provide my information, 456, John Doe. And this time it should allow me to cancel. So we'll see if that's the case. 3, 2, 1. Cancel it. Oh, it didn't work. So I may have had to refresh after changing application properties. Anyway, you'll just have to believe me, because otherwise we'll run out of time. I was using OpenAI ChatGPT basically for now, but you can actually use models running on your local machine as well, right? And you can use that with LangChain4j as well. So, you can use Ollama, you can also use Podman AI Lab to serve some models, or Instruct Lab. So in this case, I'll use Podman AI Lab, but I want to add some more stuff to my application to make it more robust, right? Because they're API calls, that's what Hugo said, and so we need some fault tolerance in case the AI model does not respond, or if there's some issue with the network or something. So we want to handle that gracefully, right? So we want to add retries or a fallback method or something. And so you can do that by, for example, adding the smallRye fault tolerance dependency, which is an implementation of microprofile. And then you can set your annotations. You can set @fallback to a fallback method. And so if the call keeps failing, then you can set, at the bottom there, you can see a message, I'm sorry, I wasn't able to create a class about topic, which was what I asked the model to do. And then, of course, we want to add some observability to our application as well, right? So if something goes wrong on production, that we can actually go and trace through our requests and see what went wrong, where was it, and how can I access the logs, and can I see some metrics about all of this, how long did the call stake and everything. So you can do that as well. So for example, by adding micrometer and OpenTelemetry to your application. So that's what I did with my final demo. And really, I did not need to configure anything else, right? So it's just like add these dependencies, and then I get that kind of out of the box. So we drop our mic. Let's open our final little demo here, and it's the Instruct Lab demo in this case. So I need to start service. So I'm using Podman AI Lab, where you can also serve models. So you have a whole catalog. You can also add your own models, and then I can start it up. In this case, I'm using an Instruct Lab model that based on IBM's Granite model. And so in a second, we should see this turn green. And I'll start this application, which is basically calling this model. So it is using the same OpenAI spec. So I didn't need to change my dependencies. But you can see here, I'm using the base URL localhost 35,000, where my service is running on my local machine. So let's start our Quark as dev again. And this time, basically, I'm going to call this model running on my local machine. And I have this AI service here, and you can see that, I'll make this a little bit smaller, that we have, again, a very simple register AI service, right? So nothing has changed here, or actually it has, because I did add the fallback with a fallback method that says could not generate an answer, and then the retry, you can retry up to 3 times, and then if not, fail to that fallback. And then basically, we're just having this /hello that says create a hello world class. Anyway, so let's try this out real quick. So localhost 8080/hello. And this is going to take a while because now I'm running this model on my local machine. It's not very powerful, so it's going to take a little time to respond, and then eventually we'll, hopefully see that it created a class. And then finally, I can also, turn off that service, and then we can see if the fault tolerance works, right? So yeah, it did create a hello world. But now let's turn off this service, and then make sure that we handle this gracefully, right? So if I hit refresh, it's going to try to call the service a couple times, right? I said retry 3 times with a pause of 2 seconds, and then, well, it did not handle it gracefully, which is kind of funny, but yeah, so it was supposed to give my, my message in a nicer way, so yeah. Thank you, demo gods, for a fun session. Anyway, so I hope this was interesting for you to see what you can do with your Java code to integrate with AI models and do that, in a fairly straightforward way. So I showed Quarkus. Spring also supports LangChain4j. I think it's slightly easier with Quarkus, but I'm a little bit biased. Anyway, if you want some free content, there's these free ebooks that you can download from the developers.redhat.com. And if you don't have time to scan this QR code, don't worry, because on this slide, you can see the link to the slides, and then you have access to those resources again. And then you'll also have access to that link, which is showing a tutorial of a lot of the things that I showed. So then you can try it out yourself. And please let me know how that goes for you. And if there are any questions, I think we can take them after this talk because I'm late. All right, so thank you, and have a nice rest of the day. Tomorrow afternoon, I'm also doing a talk with my colleague Daniel on serverless Java. So not AI that time, but we're going to look into how we can optimize our Java applications for serverless. So hope to see you there as well. Thank you.